Hey, hi guys. I hope that you guys have a great time so far. You said 20 minutes, but my train is at 7 p.m., so we can stay as long as you want. Yeah, there is a long title behind it. Where's the clicker? It's right there. Okay. So let me really guide you through the stuff what we do in Alstom. So first of all, just to introduce myself very quickly, name is Nenad Mijatovic, not so important, the right pronunciation, important is what is behind me. So I have a formal knowledge in data science and AI and machine learning, as well as a practical use of all these tools. So, and I'm really privileged to lead data science and AI teams in Alstom, where we really act as a data science and AI métier to provide the different knowledge as well as solutions for our products. So with all due respect to all of you guys, I bet that only few of you know what Alstom is, and I hope that you know, right? Thank you. And some, few of the French folks around probably know, but I bet that at least 50% of you enjoy, I hope, our trains. So what we do, what is in our DNA is that we build trains to move people good from point A to point B in safe, reliable, and a green way. Okay, so that is the most important thing that you guys need to know about us. So metro, high speed, regional trains, people movers at the airport, also the solutions which are building the signaling systems. That's what we do. So you guys are all aware of the autonomous cars. You're so excited, right? But you probably don't know that Alstom was the first in the industry who built autonomous metro. So if you go to Paris, you will enjoy riding line 1, line 14 completely autonomously without a person driving it. Pretty cool. So where we are everywhere, okay, and in a good sense. So Alstom is in more than 250 projects involved. We have a lot of people, a quarter of us are engineering, and whatever we do, as I mentioned before, we move the stuff on a safe way, okay? And that is the key. So why that is the key? Well, right now what we do within Alstom, within my group, is that we segregate something what is called non-critical and critical applications. So the non-critical applications are something that it will not cause any safety use cases for the company, okay? So anything related with the predictive maintenance, with root cause analysis, when we do the log analytics, etc., that is non-critical application. Critical application on the other side is, as I mentioned before, if you need to move the people completely autonomously, okay? So that is the mission critical application. Also, if you want to do the new way of signaling, which is called interlocking, right? That is something where the safety case is in place. And unfortunately, right now, 80% of all our effort, my effort as a data scientist and AI leader in the company, is towards the non-safety critical applications, okay? And these guys are only 20% of our business. And that is not only for Alstom, it is for all transportation companies in the world. So how we can change this tie? What should we do? And the answer is trust. So that is something what I would like you guys to take as a takeaway from this call, is making sure that we build trust when we promote the new technology. And we build that on 3 different levels. First of all, we need to sell that for our internal customers. So we are empowering our own people to use the AI in a way that we follow very strict rules. We are an engineering company. So what we need to do is we need to follow the engineering rules and a strict methodology that my team developed, right, to follow and deliver at the end the non-critical application, okay? The second one, maybe you guys, like, well, probably not you, but unless you're coming from any of the operators, and I hope that you guys are happy in that case, but all our external customers. So Amsterdam City, for example, or Paris, or London, whoever is using our solutions must have a trust in our technology. What does it mean? So that means that, you know, when I tell them something, right, they will be able to act on that with a high certainty that they will be, you know, the action will be usable, right? And finally, we are not alone in this journey. There is a lot of governmental bodies, which are, as well as standardization bodies, you know, trying to put the barriers and kind of set the rules, or in some cases, you know, provide the ways how the data science and AI should be deployed, so then we can have it in a secured way. And you guys, you know, IEEE is here. There is other standardization bodies talking about that, but, you know, across the globe, in the States, the previous talker, he just had one slide on this. In the States, in Canada, in China, in Australia, and recently in Europe, right, we basically put a lot of different regulations. So just think about it, right? So there's a lot of stuff going on out there, right, that we as the company should comply. Why? Because I have 250 projects worldwide, okay? So if I want to have a business in Europe, I need to comply with the regulations here. If I need to, you know, have a business in Australia, I need to do the stuff there, okay? Does it make sense? So what we do is we come up with our own definition of the trustworthy AI. So yes, so you can take pictures. So basically, what is it? First of all, when we develop a software, right, we treat this as a software. We need to make sure that it is valid, right? So it complies with the certain requirements. Writing the requirements for the AI is super hard. Have you guys ever written requirements for AI software? Few of you, maybe, no? It's very, very hard. So when you have the safety critical application, you know exactly what you should put in your shell statement, so then you know how the software should react, right? That is very vague in the case of the AI. The second one is basically whatever we do, it must be reliable. So someone will use my solution. I will give you an example. When we suggest that a certain part is going to break, we tell that to the maintainer. Maintainer needs to go in the middle of the night underground to fix the part. Just imagine the frustration they might have if that part is really not, oops, this was not me. Sorry about that. Something is wrong with, okay, good. So I'm not touching anything. All right, so you need to make sure that, you know, they will exactly understand that is the problem. They will recognize the problem and fix it. Why? Because they will be either super happy or they will be extremely mad. All right, we don't want to have them mad. The second one is, there is a lot of stuff going on here. So every time when I talk about AI, there is a certain part related with the security and safety, and that is, you know, for us, it's on the next level. So whatever our colleagues said here about security, bless you, making sure that, you know, they are, you know, it is resilient, blah, 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 all this stuff, we need to put it on the next level, and that means that we are not going to put any harm of the people enjoying riding our trains, okay? Next one is, and I didn't put everything in order, but this is where we started. Where we, ages ago, 8 years, started using all these data science and AI in Alstom, experts, métier, didn't want to trust it, okay? So if they didn't understand how the algorithm worked, they will not use it, right? So the part of the explainability was huge, and still it is, in Alstom. The next one is, you know, when you provide the output, and many of you guys, and I'm data scientist by training, okay? When you talk about confusion matrix, false positives, blah, 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 none of these things make sense for the experts, right? So you need to give them the right interpretation of the results in order really to start using and enjoying the stuff, right? And then finally, when we talk about the fairness, we are industrial company. We take care of all the GDPR stuff, etc. Right? But for us, fairness goes in another direction. How is that? Well, we are super proud that our systems, our trains are reliable, okay? So the number of data points which are really interesting for me as a data scientist, if something is broken, etc., is very, very small, okay? So we need to come up with very specific methods to make sure that we are going to have the right data set to fulfill the job. And finally, when we talk about the safety is, there is no, safety in terms of the way how the AI will react. It's basically, making sure that my AI is not going to harm anyone using it, okay? And now, let me just go to the next one. Okay, beautiful. Now we're right spot. So Alstom, our beautiful trains. I'm not coming from the industry, so I have no clue how to build a train and stuff like that. But the people ask me to help them when we maintaining our trains. So the first problem that we faced a decade ago is something what is called predictive health maintenance. What is that? Well, Alstom makes parts of the train, but also we buy parts from our OEMs. All right? So what we do is every part will have a certain warranty period, say 6 months. Fantastic. But we realize that sometimes we replace the part which is in a very good condition, so that means, not really sustainable business. And the second one is sometimes happen that the train will not be able even to move because one of the part broke before the expiration time. Okay, does it make sense? So what we did is we put an algorithm, we started collecting the data, we understood how the operations of the train works, and then we started predicting when a specific part is going to break. Okay? And then all these PHM stuff or predictive health maintenance about all these different pieces of the train right now in our portfolio. So I have to say that I'm super proud that we have the widest portfolio of the predictive maintenance in the industry. Okay? The second one is the catenary or pantograph detection, where we're using the computer vision to understand what is the remaining useful life for the device. That device basically provides electricity and electrical power right to the train. So you can just imagine how important that part is. We also develop an algorithm which detects when the specific pantograph out of all is going to break during the test and validation phase. By the way, test and validation phase is one of the most expensive phases when we're testing and promoting the new trains in the area. The next one is, and I guess you guys, some of them you can feel any of this, is when we have the autonomous metro, there is no guy who is going to check what is going on in the back, right? So we need to have the system which will reliably detect that there is no person standing at the door. Okay, that can be super, super dangerous. So just imagine how reliable that algorithm must be, because we're either go or no go with that particular train. The second one is and that was a funny story. So our office is at the end of the line 14, and once I saw the person who was completely freaked out because what happened is that person did not realize that was the last station, so they stayed in the metro, right? So metro went in a depot, and after 10 minutes, he was ready to go. However, the guy was completely freaked out. So what we do is we are detecting reliably if there is a person left in the last station or a luggage. So I'm not sure if you guys visited Paris these days, especially during the Olympic Games. The SNCF or NRTP, they put a big, what's the name, message that pick up your luggage not because they care that you're going to lose it, right? But because if we detect that there is a luggage left in a metro, we need to call the police, all right? To basically check if there is any dangerous stuff over there. How we do all this stuff? We're doing this stuff with the solutions which we call the train scanner, where basically I simplified that for you. It's a place with a lot of different sensors, video, audio, vibration, LiDAR, name it. It's a great place for me as a data scientist to enjoy the data. We basically collect all this data, we put in a health hub, and that is where my algorithms live, right? So all this stuff that I explained to you, it's in this particular solution. If I move on to the signaling and infrastructure, so we talk about the trains, now we talk about lights, go, stop, 20 kilometers per hour, 30, whatever, right? As well as understanding the rail, we have a lot of solutions which are detecting issues with the track, with point machines. So point machine is the machine which basically diverges the train from one track into another. It is a critical piece of the equipment. And there is a famous line 13 in Paris where you can be completely stuck if this thing is not working. And I also mentioned before that we are moving the stuff and the people extremely efficiently, and we care about energy a lot. So what we do is, with our analytics, we first of all understand the behavior of our drivers. We educate them if someone is not performing or not following the engineering rules of driving. But on the top of everything, we are extending that and trying to improve our energy efficiency for all our subsystems, okay? And another topic that I would like to mention to you is the video analytics, and that is super cool. Again, in our industry, putting new sensors, putting something what is absolutely unnecessary, it's a big no. Okay, I just cannot justify putting the new sensors on a train unless it is really, really important. So what we do here is we always try to tend to reuse the existing data set. Here you can read video from the CCTV cameras, where again we are making sure that we're not infringing GDPR and all other stuff, detecting how many people are in a train or on a station, basically based on which we can improve, release more, or reduce the number of trains to adjust for any changes in the system. As well as we are inclusive, because we're detecting the people with limited mobility, and then we're assisting them where will be the best place for them to enter the train, as well as sit in a designated area for them. Awesome. The next one is the two personal stories. The one is that was my second day commuting to the office, and the train was stopped in the middle of the tunnel. I'm claustrophobic. It was not fun. Basically, what happened is there was lack of the radio communication between train and the ground, and there is no communication, nothing can move, right? So what we did is we pick up the brain of our radio expert, and we implemented in our algorithms, and right now we have that as, they changed the name, which I don't like, but now it's called AI monitoring tool. So you can think of, you have the expert knowledge that we dump into AI, that AI is looking at the data, at the signals in the radio communication and detecting what is the problem. Is that on a train? Is that on the ground? Or maybe that is in the radio channel in between the two. The second one is, have you guys ever looked at the log files from the Apache web server or whatever, right? It's fantastic read, right? No one wants to read that. Even the people who develop that, they don't want to read that crap, okay? So what we did is, we developed an AI back in the day, before all this ChatGPT stuff, where we are detecting anomalies in log files, but more importantly, we're detecting the most probable root causes for all these issues, okay? Now, it is a great place to be. And as a data scientist, AI folk, it's really super, to play with all these different tools. And again, guys, this is only one piece of the applications that my team developed so far, right? So we have much wider range. However, we are here to make sure that our business is more efficient, then we can be faster to the market, and we can reduce energy, and most importantly, we can reduce the CO2 emission. So overall, globally, the company is targeting 0 CO2 emission by 2050, right? So whenever we have, and that's why, with all due respect to other folks, when they talk about, okay, I have N number of projects and only 0.5 times N succeed, that is not the case in my team, right? So what we do is we set up exactly the KPIs that we want to follow. So do we want to be more reliable? Do we want to be more accessible? Do we want to be, making sure that we are faster to the market, or we are reducing the energy? Based on that, we understand if we have the data set or not. We also must have the support from the métier, because we're just a poor data scientist. We know nothing about the domain, okay? And finally, what is also super important is I don't have commodity always to deploy my algorithms whenever I want. So I need to put them on a train. Just imagine, this thing is old. I need to put them on a wayside. That thing is also old. Or I have a little bit more kind of freedom if I need to put it on a cloud, all right? So these are kind of the main things that we're following when we are trying to deploy our stuff. So overall guys, we're done. So, but really what I want to do is here, we are big. I'm super proud of the team. We have great stuff going on, but we are not alone in this journey. And even here, during this summit, I saw that there is a lot of people that we can collaborate, and really only as a team, as everyone get together, we can really build that trust in a technology and push it for different use cases. Thank you so much for your time.
Thank you so much. So any questions for Nenad, who gave a lot of very practical examples. So please go ahead.
Hi, James Amanian, and thanks for Trains United States. Do you have any real-time operating systems that you have to interact with? And do you have any advice about, with AI systems being non-deterministic and maybe taking some time, feeding those systems that may have low compute and low bandwidth as well?
That's a great question. So basically, first of all, we do use the real-time operating systems on our wayside devices, where we need to make sure that there is a state machines and all this stuff in place, and where we also put our algorithms to detect anomalies which are critical to kind of be detected in real time. There is for some of the topics that I explained, the bandwidth is super kind of limited. So unfortunately, we need to offload the data when the train is in a depot. Okay, but in the case of the autonomous trains, everything must be real time. Does it make sense? Anyone else?
I'm wondering, in the Netherlands, we have a train station that sometimes a train system that looks more like metro system. Sometimes it's said because of the frequency and the network density. But I think they struggle a lot with automatization, and I wonder if you have any vague ideas about these challenges.
So as I make a joke always is, if something is working, that is because of me. If something is not working, that is because of Alstom. But to be honest with you, I'm not sure. I don't know exactly. The solution that I explained to you, which is detecting the radio problems, is implemented here in Amsterdam, right? And I have to admit that we reduce the number of something what they call the emergency stops. So that is when a metro stops in the middle of nowhere and you don't know what is going on, by 80%. Okay, so in that sense, I can say that we are better. but I'm not sure about other topics that you explained. This is not recorded, right?
Any other last questions? Okay, I want to thank you very much, Nenad.
And guys, I mean, we are hiring, so if you are data scientists, the AI folks, come and talk to me, okay?
All right.
Thanks so much.
Wonderful.